The law of conservation of angular momentum is one of these laws, like the law of conservation of energy, that's really powerful and governs a wide range of phenomena. It says that the angular momentum of a system of particles around a point in a fixed inertial reference frame is conserved as long as you have no external torque around that point. And that means that your angular momentum doesn't change with respect to time. So you end up with a constant angular momentum over time. And I might even write that as my initial angular momentum is equal to my final angular momentum. As long as there's no net external torque, that will be true. This gives us ways that we can manipulate our rate of spin. Understanding that we have the ability to change our moment of inertia by changing how tight or wide our arms are spaced, we can be spinning like an ice skater, and with our arms way far out, we have more mass farther away from our body, so our moment of inertia is higher. As we bring them in tighter, we bring the mass closer to the axis of rotation, and that decreases our moment of inertia. By the conservation of angular momentum, that will increase our angular velocity to compensate because our angular momentum stays the same. In practice, you're losing some angular momentum to friction during this process, but you still see that result. And if you have a spinning chair like this, you can try spinning around and pulling in your hands to see this effect. Or if you're creating a galaxy, you can try letting the galaxy spin around and see that as that initial gas that we started with, that cloud of gas and dust that was rotating, as that progresses over time, since there's no net external torque from outside of the system, we end up maintaining that same spin as things coalesce and planets accrete, and we end up with orbital spins of our planets and motions of our planets that are in the same direction as the original spin of the overall thing. And this is the answer to, like, why are all the planets kind of spinning the same direction? It's because of conservation of angular momentum.